Welcome to the program. So for today, I want you to not passively watch this video. I want you to try to do what I do in the video. Okay? So we have 3 cosine x as our first input. These are 5 different inputs that we're going to throw into GeoGebra, and we want to look at the output and compare it to the cosine of x. So let's do that now by pulling up a browser, going to GeoGebra, and clicking on that first link there. When I do that, I've got this cog up here. I'm going to click on that and go to settings, and I'm going to change the x-axis value to units to pi. Okay? And now that I've done that, let's just jog our memory and do cosine of x. I type in cos space x and then I hit enter, and there's the parent function. We call it the parent function because there are infinite ways to manipulate this graph, but this is the original graph with an amplitude of 1. So it goes up to 1, it goes down to -1, doesn't go beyond that, and the period that we talked about last week goes from 0 to 2 pi. You can know that because it starts to decrease at y equals 1, and the next time it decreases like that is at 2 pi. So the period is the distance, the horizontal distance in which the pattern emerges. The pattern emerges from 0 to 2 pi, so that is the period. So now we're going to transform this by throwing a 3 out in front of the cosine and then hitting enter and seeing what happens. Okay, notice the amplitude increased greatly by a factor of 3, which is what we expect because we put a 3 out in front of the cosine. So now, instead of going from 0 to 1, our outputs are at 3. When the input is 0, and x is 0, the output is 3. Think of it as a box. When the input is pi over 2, the output is still 0, as with the parent function here. But when the input is -3, when the input is pi, the output of the parent function used to be -1, but when the input is pi, the output of 3 cosine x has an amplitude of -3. The output is -3. Okay? Back at 3 pi over 4, we're at 0 for both, and then at 2 pi, when the pattern emerges, we're at amplitude 3. So we see that the output of the graph has been vertically stretched by a factor of 3. So that answers the first question here. The output of the graph has been vertically stretched by a factor of 3. The zeros to the function remain the same. Zeros meaning that when we look at the graph, where the graph actually touches the x-axis, here, it's the same for 3 cosine x and cosine x. It's the same. Alright, so let's turn off our 3 cosine x and leave the parent function on by leaving that dot there. And now let's go to the next one. The next one is what? -3 cosine x. What do we expect to happen there? We did this a little bit last week. So cosine -3 cosine x. Alright, so what happened? With the parent function, we have an output of 1 when the input is 0 radians. But now, for the new graph, its amplitude is still 3, but it's negated. So all the inputs for the original are the same for this -3 cosine x, but the outputs are negated. It's sort of like when we did the table and we just negated the values. So at pi, the parent function's at -1. So we're multiplying -3 times -1 to get a +3 output. So the inputs are the same, but the outputs have changed by a factor of -3. So it's inverted. And we could see that more clearly by turning off cosine x and turning on 3 cosine x. So 3 cosine x is the blue. You can see from the colors here. And -3 cosine x is that one. Okay. And so how do we word that? Let's go here. You'll be doing it in assessments. We say the output is negated compared to 3 cosine x compared to parent function. There is a vertical stretch of 3, stretch factor of 3. Okay. So cosine x plus 3. That's the next one we've got to do. And so now what we do is we turn this back on, cosine x, and we'll do cosine of x plus 3. So what did it do? It shifted the graph. Here's our parent function, cosine x. So cosine x up 3. So if you look at this where it begins, where 0 radians are the input, we go up 1, 2, 3. So there was a vertical translation up 3 units, and that's for all of them. So if here we are at pi as the input, we're down at -1 for the output right here. So I go 1, 2, 3. It still works. It works for all of them. These lines are sort of, you can't say really parallel, but they are the same. It's the same graph, but it's shifted up 3 units. Okay, so that's what we're going to put. The output is shifted up 3 units from the parent function. Okay, cosine x minus 3, we haven't done it yet, but we would expect, here's cosine x, right? So if I do f of x, and I don't have to type the f of x stuff, I just do cosine x minus 3. And the new graph here, I believe it's blue or purple, has been vertically shifted down 3 units. Okay, so for the input, the parent function, the output to the parent function at theta equals 0, 1, 2, 3. So this is a vertical shift down of 3 units. The output is shifted down 3 units from parent function cosine of x. And the last one we'll do, what happens when we take something like cosine of x and put a plus 3 inside parentheses? How does that change the graph? Alright, let's take a look. So if we do cosine of x, parentheses, actually before we even do that, let's turn off that shift down of 3 so that we only have the parent function up. It's good to have the comparison of the original, that's why they call it the parent, with the sort of offspring, because we're building functions today. So we do cosine of x is it plus or minus? I believe it's plus 3 in the parentheses, plus 3. Just want to make it sure I'm consistent here. Cosine of x plus 3. Alright, so that didn't result in a vertical shift, and that is the most important thing to learn today. What we had instead of a vertical shift was a horizontal shift. So the parent function being here, it's sort of hard to see when they're both on top of each other, but if you look at where, let's just look at our values for theta is 0 and theta is pi. Alright, we can even look at theta is, well, theta is 2 pi will be the same as theta is 0. So we'll look at 0 and pi for the parent function. It's 0, it's positive 1 for 0 and negative 1 for pi. So now let's look at x plus 3. Alright, so what happened is the graph has been shifted, but not vertically. Horizontally, negative 3 units. How do I know negative 3? Because this right here is negative pi. So that's negative 3.14. So what used to be here has gone over negative 3 units, okay? And that's going to be the same for our, when we're at, the parent function was here for pi, we had a negative 1, but that has also been shifted over 3 units here to here. So, and we'll see that when I do that. So there's the shift. It started here, but because we're now adding 3, we go left 3 units and we end up there. So we say a shift plus 3 will result in a shift left of 3 units. So the graph is shifted left 3 units from the parent function cosine of x. Thank you for watching.